Hello everybody, welcome to week 4 of our course on the history of artificial intelligence. We are going to hit the midpoint of our class this week, and this week, appropriately, we arrive at one of the biggest, most significant turning points in the history of AI. So in the first part of the course, we looked at systems built around logic, symbolic reasoning, and carefully constructed rules. In those earlier approaches, intelligence was something that researchers tried to build by explicitly telling a machine what to do in very specific circumstances. But by the 1990s and early 2000s, and that's the chronology for this week's explorations, this understanding of AI began to shift in a very, very major way. So increasingly, what was changing then, AI came to mean systems that could learn from data, massive amounts of data. These machines could improve through experience, they could recognize patterns, and they could solve problems at a scale that earlier generations could barely imagine. Part of the reason why? Well, computer technology was advancing also by leaps and bounds, which enabled this to happen. So the central theme of this week is simple, but it's very important. Machine learning did not just introduce new techniques into AI. It helped truly redefine and reshape what AI was. Now, when we get to our core materials that we're all going to be reading this week, you're going to see this transformation from several different angles. First, we have Tom Mitchell's Introduction to Machine Learning. This gives us a very clear definition to what this field is all about. He describes machine learning as the study of how computers improve their performance through basic experience. Sounds very human-like. And that may sound very straightforward, but historically, this marked a profound shift. Instead of programming every rule directly, think about expert systems from last week like Myson, researchers increasingly created systems that could adjust themselves based on examples, outcomes, and data. Then we have, after that, two what they're called as crash course AI videos that I think help make this shift more concrete. So we have one on supervised learning and one on reinforcement learning. The supervised learning video shows how a machine can learn from labeled examples and then apply what it has learned to new situations in the future. The reinforcement learning video introduces a different kind of model where a system improves itself through trial and error and also through feedback and reward situations. So together these two videos I think present a pretty good understanding of how AI was becoming less about fixed instructions and more about learning from experience. The next part of the core this week is a reading by Fayyad and other authors, and this broadens this story about machine learning even further. Their discussion of knowledge discovery in databases shows how machine learning became closely connected to the challenge of finding meaningful patterns in massive data sets. Now this matters historically because it reminds us that AI was no longer just about, again, clever rules or elegant programs. It was increasingly about the data itself, collecting it, organizing it, processing it, and deciding what counted as useful knowledge, and then gaining experience from learning from it. The point I think becomes even clearer in the introduction to the Dean and Gemawat article on something called MapReduce. So once researchers and companies began relying on truly enormous amounts of data, they needed a practical way to process it. And so MapReduce helped to make large-scale distributed computing possible in a much more efficient and manageable way. So historically, this is crucial because it reminds us that advances in AI do not always just come from theory. They also depend on infrastructure. And we're going to take that a little bit further with the final piece from our core readings this week, and that's from the Smithsonian on the Mark I perceptron. And this reminds us that some of these ideas about machine learning were actually older than they might seem. Neural networks and learning systems did not just suddenly appear in the 1990s. Frank Rosenblatt had already been exploring these types of ideas actually decades earlier. But by the late 20th century, new computing power and much larger data sets, this massive data combined with unbelievably new and powerful computers, made these approaches far more practical and influential and were able to be realized for the first time. So this week is also a reminder that in history, ideas sometimes matter most when the world finally catches up to them, or in this case, the technology needed to catch up with the ideals of what AI could be. Okay, so that ends the core readings this week. And next we have, as always, 3 different learning paths for you to pick one of your choice. Learning Path A focuses on chess, one of my favorite topics, and the famous contest between world champion Garry Kasparov and the computer program known as Deep Blue. Now, on the surface, this is the story of a machine finally defeating a human world champion in chess. But at a deeper level, it raises an even more interesting question than that. And that is, what kind of intelligence was on display that enabled Deep Blue to beat the greatest human chess player in the world? Well, the readings and the documentary that you'll watch suggest that Deep Blue did not win by thinking like a human in any simple sense at all. Deep Blue relied on speed, search capabilities, evaluation functions, and expert tuning, and of course, a massive intellectual database of past chess games. And this is important historically because it challenged the assumption that was long made among AI researchers that machines had to think like humans in order to outperform them. And this certainly was not the case with Deep Blue. Next we have Learning Path B, and that turns towards a topic called data mining and also the growing power of personal data. You're going to be reading a Wired magazine piece on DoubleClick and Abacus, and this captures a central moment in the late 1990s when personal information was increasingly treated as a valuable commercial resource. Mitchell's later essay helps show how machine learning itself developed into its own field, especially in cases where hand-coded rules were no longer enough. Then we have a computer file video for you to look at, and this introduces the basic logic of what data mining actually is. And then the Persuaders video helps connect these developments to targeting, persuasion, and also profiting from data mining. So, taken together, all these pieces in Learning Path B, the path shows that machine learning was not just changing computer science; it was beginning to reshape daily life by placing a value on this basic human personal data. The final learning path C, explores in more detail the recommender systems that we looked at in the core readings and the way that machine learning quietly became part of the entire internet experience. So we have an article from Amazon on collaborative filtering, and it shows how recommendation systems became scalable and effective across massive product catalogs. The editorial on machine learning for the internet expands on that picture. Then we turn to most everyone's favorite television show and movie watching site, which is Netflix. And Netflix presents an explanation of its recommendation system, and it shows how machine learning affects what people are encouraged to watch. Every time you turn on Netflix, you are being given a recommendation of what it thinks you might like to consume. And the way it does that is through AI. So this video on recommender systems helps to explain the logic behind these tools. So Learning Path C then shows how machine learning truly moved from the lab into everyday life by shaping our very core being in terms of attention, choice, and taste, and what we consume. After the learning materials this week, again, we will then turn to the discussion question, which we'll talk about one of the most important questions that we have faced so far. And that question is, how did machine learning change the meaning of what AI was? Did machine learning in the 1990s and early 2000s, did it represent a true transformation in the field, or was it simply a new method to pursue older goals? And as you think about that question, what I'd like you to do is draw from both the core materials and also whatever learning path that you chose. So you might focus on supervised learning, reinforcement learning, data mining, neural networks, recommender systems, or large-scale computer systems like MapReduce. And so you're going to, based on that experience, you're going to think about, well, what did machine learning allow AI to do better in this era than earlier rule-based approaches like with expert systems? And also, what new limitations, trade-offs, or social concerns emerged with that change? Now again, we have a hands-on experience this week, and I'd like you to spend a little bit of time experimenting with something called TensorFlow Playground. Now this is meant to be hands-on like the earlier hands-on AI components of the class. And it looks complex, but it's really meant to be low pressure. It's not supposed to be overwhelming. Well, maybe in a sense it's supposed to be overwhelming, but it's supposed to be low pressure and fun. So keep that in mind when you're doing it. The goal is not to master it or understand every little thing about the TensorFlow Playground. It's really just designed for you to explore. And this gives you a way to explore machine learning. So try changing the data set, adjust some of the hidden layers, experiment with some of the learning settings. When you're doing this, notice what helps the model improve and also what causes the model to struggle. And again, even if this feels a little bit confusing at first, that's fine. In fact, really that's kind of part of the point. Machine learning often only works in ways that feel less direct and less transparent than some of the earlier rule-based AI. And noticing that difference, I think, helps us understand why this shift to machine learning was so significant and why it mattered and still matters so very much. So the key takeaway this week is that machine learning transformed AI in truly fundamental ways. It moved the field away from the idea that intelligence had to be built mainly through explicit symbolic rules. In its place came a growing emphasis on adaptation, statistical inference, pattern recognition, and also large-scale computation with massive amounts of data. That opened up powerful new possibilities within the field of AI, but it also introduced new dependencies on data, infrastructure, and systems that often became much more difficult for humans to interpret and in some cases understand. So by the end of the week, I hope you'll see that machine learning was not just another chapter in AI history. It was a major turning point that reshaped how researchers defined intelligence, how they built intelligent systems, and how those systems began to enter everyday life, even in places where we weren't realizing that we were confronting AI in our daily lives. So, as always, I look forward to seeing where your learning paths take you, and we will meet in the discussion board to discuss them. Have a great week.